Welcome back, students. We'll be looking at section 4.1, terminology for solving systems of linear equations by graphing. So in our first blank, we're going to put the word system of linear equations or linear system. So these are two ways that it could be worded in the problems when they want you to solve these. And these basically consist of two or more linear equations with the same variables. So remember, linear equations are equations of a straight line, okay? We've been solving these types of equations, so you're not going to see anything new with how we solve them. What is new is we're going to be solving more than one in a problem. We'll have two of them at least that will be solving each problem. And then we're going to see how they relate to each other. So that's really the new part of this. So examples of linear systems you may see in any of these forms. But one thing I want you to notice is it's not anything new that you haven't been seeing for a while now. So don't think that this is going to be completely brand new. It's just taking what you've learned so far in this class and then taking it a step further. All right, so our first instruction says determining whether an ordered pair is a solution to a linear system. So remember, the word system means we're going to have more than one linear equation, and we're going to see how these solutions relate to this system. In our first example, it says determine whether the ordered pair 2, 5 is a solution of the system. The system that they give us is basically these two linear equations. And we want to see if this ordered pair, 2, 5, is a solution to these equations. For it to be a solution to the system, it has to work in both equations. If it only works in one or it doesn't work in either one, then it's not a solution. It has to work in both. So we're going to be solving this problem two times basically, because we have to put our solution in each of these equations and solve to see if it is a true solution. So let's start with 3x minus 2y equals -4. We're going to plug in both the x and the y that they gave us, the 2 and the 5. So I'm going to say 3 times 2 minus 2 times 5 equals -4. We get 6 minus 10 equals -4. 6 minus 10 is -4. And our two sides match. So for now, it looks like it will be a solution to our system. So I'm going to circle yes. Let's look at the other equation. 5x plus y equals 15. Again, we're going to substitute in the 2 and the 5. So I get 5 times 2 plus 5 equals 15. 5 times 2 is 10, and then I have the plus 5. 10 plus 5 is 15, and both our sides match, so it's also a solution to this equation. So we would say, yes, this is a solution to the system because it works for both equations. Let's look at the next one. Determine whether the ordered pair 1, -2 is a solution of the system. Again, we're going to work each equation with this ordered pair and see if it works. So I'm going to plug in 1 minus 3 times the -2, and that equals 7. I get 1, -3 times -2 is plus 6. 7 equals 7. It looks like so far this is going to be a solution to the system, but we still need to check the second one to make sure. 4 times 1 plus a -2 equals 5. I get 4 plus -2. That becomes 2 equals 5. 2 does not equal 5. So this particular ordered pair is not a solution for this linear equation. So it is not a solution to the system. Again, it has to work in both equations or all the equations that they give you to see if it really is a solution to the system. All right, let's look at solving linear systems by graphing. So the solution to a linear system is the point of intersection of the lines. So where they cross each other, basically. So if you have two lines like this, the solution to the linear system is right here, where they actually cross. That ordered pair is the solution to both of those lines. That is the only place that they share a coordinate. So that's why it would be the solution. Let's look at some examples. We have way number 1, and then we'll look at way number 2 to see a different way that we can kind of look at this. But the first way is we're going to use the x and the y intercepts with a third coordinate, okay? So we're going to plug in 0 for x. So we get 3 times 0 minus 2y equals negative 4. That gives me 0 minus 2y equals negative 4. And then I have negative 2y equals negative 4. I'm going to divide by that negative 2. And I get y equals 2. So my, sorry, failing for words here, guys. So my y-intercept, that's the term I was looking for, is 0, 2. So I'm going to go ahead and plot that here. Now let's find our x-intercept by plugging in the 0 for the y. So I get 3x minus 2 times 0 equals negative 4. 3x minus 0 equals negative 4. Divide both sides by 3. And I get x equals negative 4 thirds, which is the same as negative 1 and 1/3 if I turn it into a mixed number. So I get a negative 1 and 1/3. To graph that, I'm going to go to, let's see here, negative 1 and 1/3 is about right here. So that's my second coordinate. I'm going to find a third coordinate, 1, with some y. So we've got to plug that in and see what that third coordinate is. So 3 times 1 minus 2y equals negative 4. 3 minus 2y equals negative 4. I'm going to subtract that 3. Move this up a little bit. I end up with 0 minus 2y equals negative 7. I'm going to bring that up over here just a little bit so that we can finish this one out. Divide both sides by negative 2, and my y equals negative 7 halves. All right, so we have negative 7 halves, which is the same as negative 3 and 1/2. So I'm going to plot that. I go to 1 and then go down to, oh, no, actually it's a positive because we had 2 negatives being divided. So that's actually a positive number. All right, so now we're going to go to 1 and then up 3.5. So it's right here. And I'm going to connect, creating my line. All right, now we need to solve with our x and y intercept on our other equation. So I have 5 times 0 plus y equals 15. 0 plus y equals 15, so y equals 15. That's going to be tricky to plot because we don't, our graph doesn't go out to 15. So it's going to be somewhere, you know, like way up here. So let's find 2 more coordinates so that it's a little bit easier for us to plot. Let's put 5x plus, our y is 0 this time. So 5x equals 15. I'm going to divide both sides by 5, and I get x is 3. That'll be easier to plot, 3, 0. So let's plot that here. Now let's use the 1 for our x and see what we get for a y. So let's see here. Let's do 5 times 1 plus y equals 15. I'm going to get 5 plus y. Subtract 5 from both sides. Not divide. Subtract. And I get 0 plus y equals 10. So y equals 10. All right, so again, that's not quite on our line, but let's just see if we can get it somewhat close. It's gonna be something like this. Let's see, this one I probably need to move over just a little bit so that it'll line up a little bit better. Probably about like this. All right, so let me connect these. This is not really pretty, is it? Let's see here. Going to be something like this. All right, in your homework and stuff, it'll work out nicer, but the point that I want to show you is that, let's see here, let me redo this because this one's not working out overly well either. All right, let's draw this again. That's better. And then let's draw this one again. Oh. Okay, that actually demonstrates what I needed it to demonstrate. All right, so what I wanted to show you was right here where they intersect. This is their solution set. That is the only coordinate that they share. That is the only x and y values that will work for both equations. So I'm going to put in my x is 2 because it's over 2, and then up 5. So my y value is 5. All right, now let's look at way number 2. To me, the second way that I'm about to show you is much easier. It has less work. And it uses the slope-intercept form for graphing. And to me, that is much easier because we end up with a starting point, we end up with a slope. We're not having to find all these values. And we're able to plot it easier because we have, hopefully, our coordinates on our graph rather than these large numbers that we were having to work with. So let's start here in our first one. Switch to a marker. All right, so I'm gonna get y by itself because I want it in the y equals mx plus b form. So subtract the 3x, subtract the 3x. I get 0 minus 2y equals negative 3x minus 4. Rewrite that. I'm going to divide everything by negative 2. And I get y equals 3/2 x plus 2. Negative 4 divided by negative 2 becomes a positive 2. And I'm going to use this to graph my line. So my starting point is 2 on my y-axis to find my second coordinate. I'm going to go up 3 because my slope is the 3/2. So I go up and then to the right. So 1, 2, 3, and then to the right 2. 1, 2. So this is my second coordinate. Now I'm going to create my line as carefully as possible. This is why I would recommend using a ruler when you're doing this on your paper to help you out. It's kind of difficult to do this on the iPad with a ruler, but for you, I would recommend on your paper, use a ruler, some kind of straight edge. You can use another page as a straight edge. I've done that before. All right, let's do our second one here. I'm going to, again, get y by itself. So minus 5x minus 5x, 0 plus y equals negative 5x plus 15. So I end up with y equals negative 5x plus 15. My starting point is the 15, my slope is the -5 over 1. So that means down 5 over 1. All right. So let's see here. Again, it's going to be a little tricky to plot this one just because of the 15. But I'm going to come way up here and I'm going to plot my 15. I'm going to go down 5. So let's see, we would end up at the roughly 10 and then over 1 about right here. I'm going to go down 5 again and end up at 5 and then over 1. Just to give me a second coordinate, I'm using my slope to help me find multiple coordinates so that I have a better chance of getting a more accurate line. From there, I'm going to go down 5 and over 1. So I'm right here for that other one. All right, so I'm going to erase this one just because it's not lining up as nicely as I need it to. But it gave us a frame of reference to at least start from. So now I'm going to switch to my marker here. Connect my coordinates and we have our line. And this location right here, again, is where they cross. This is the same exact problem. I'm just showing you a different way to find it. So now I can say that my solution set, again, is 2, 5. Notice the amount of work between way 1 and way 2. Now, if way 1 makes more sense to you and it helps you to be more accurate, then by all means do way 1. Don't let the amount of work persuade you to do a way that doesn't make sense to you. But if you understand way 2, which hopefully you do by now because we've been doing it a lot, then use way number 2. It's much simpler and a lot less work, so you'll be able to go through the problems at a quicker pace, just because you're not having to test all these different numbers to see what you end up with. Now let's talk about 3 types of linear equations. We have 3 different systems here. We have system 1, which is the intersecting lines. When you have intersecting lines, your slopes are different. Okay, your slopes are not going to be the same, and they're not going to be opposite sign reciprocals either. They're completely different. It's going to possibly have a y-intercept. Okay, it depends on the equation. Depending on if a line is a vertical line, you may not have a y-intercept for that vertical line, but you could still have intersecting lines if your other line intersects with it. So that's why I said it depends. Most of the time you're going to have a y-intercept, your B letter, okay? If you don't have a B, then put a +0 so that you have a value to plug in for your B, okay? The solutions will be a coordinate. So it'll be an XY coordinate. And the term that's going to be used as far as the type of system relating to each other is neither. Okay. Now let's look at system 2. System 2 is a group of parallel lines. These lines are lines that will never touch. They will always be the same distance from each other. Okay. Their slopes are the same. They will have the exact same slope. Their y-intercepts will be different. So that means their B will be different. The solutions will be no solutions. They will never touch. So they never share a coordinate that will work for both of them. To have solutions that they share, they must touch. And parallel lines don't. So that's showing you the difference between intersecting lines and parallel lines. Intersecting lines is only going to have one solution, where they actually intersect. Parallel lines never intersect, so they will never share a solution. So if you end up with a problem where it says you have no solutions, then you know you have parallel lines that you're going to be graphing. System 3 is basically the same line. So they'll give you two linear equations, but when they are checked, you'll actually realize you have the same equation. One might just look slightly different because it has larger factors than the other one, but if you were to simplify them, they would be the exact same equation. So that's why it says same line. So their slopes are going to be the same. Oh, let me change colors there. Their y-intercepts will also be the same because they're the exact same line. So everything is going to be the same. So the way you would write your solution is like this, except for in this location right here, you're going to put your actual equation. I'm going to put y equals mx plus b for now, just because I don't have an equation to plug in there. But that's, you would actually put the equation and your answer would look like that. All right, so on system 1, we said it's neither. On system 2, it would be labeled inconsistent. And then on system 3, it would be dependent. Dependent because they are the same line. All the solutions are dependent on each other, okay? Now you'll notice the way I have this one drawn. I have it drawn like this because I need to indicate that there is two equations that are the same line. So I have the dotted line under the solid line just to indicate that. Now, when you actually enter your line on the graph in the program, you're only going to plot one line. So yours won't look like this. You'll just have the one line there. Don't plot two lines, okay? All right, now let's look at solving special systems. So again, I'm going to get it into the y equals mx plus b form. That's the easiest way. So let's go ahead and do this first one. I'm going to subtract 3x, subtract 3x. I end up with 0 minus y equals negative 3x plus 4. I'm going to rewrite that. I need to divide by negative 1 to get rid of that negative with the y. So I'm left with y equals 3x minus 4. My b is going to be 0, negative 4, and my slope is 3 over 1, which is a rise and then to the right. Excuse me. For my first coordinate, my b, 0, negative 4, I'm going to be right here. I'm going to rise 3 and then go over 1. So this is my second coordinate right here. So I'm going to try to draw this as straight as possible. That might be slightly off. We'll have to see when we plot our second line and see how they interact. All right, so now let's do the second one. I'm going to subtract 6x from both sides. I get 0 minus 2y equals negative 6x plus 12. I'm going to rewrite this. Divide both sides by negative 2. I get y equals negative 6 divided by negative 2 is a positive 3x. 12 divided by negative 2 is a negative, let's see here, a negative 6. Yeah, there we go. All right, so my slope, or excuse me, my y-intercept on this one is going to be 0, comma, negative 6. And then my slope is 3 over 1. Well, looking back at my rules, and this is why I hesitated for a second because I was thinking it was going to be something else. But looking back at my rules, if they have the same slope but different y-intercepts, I'm going to have parallel lines. So if I remember that rule, then I know what my graph should look like. So let's go ahead and graph this and see if we actually end up with parallel lines. If I don't, then something's not right. Something's off in my work and I need to go back and double check everything. But my starting point is going to be a -6, 0, -6 right here. And then I'm going to go up 3 over 1. So I end up right here. And my lines are really close, so I need to be careful just so you can see that they are in fact parallel lines. They're really close to each other, but they are parallel. They'll never touch. Now our solution set, remember, if they're parallel, is no solution. They will never touch. They will never share a coordinate. All right, let's look at this special system. So I'm going to start with the x minus 3y equals -2. Solve for y. So minus x minus x. I end up with 0 minus 3y equals -x minus 2. Divide everything by -3. And then I get y equals 1 over 3x plus 2/3. My b is 0, 2/3. And my slope is 1/3. So up 1 to the right 3. All right. So I'm going to go down 2/3. That's I'm going to go up 2/3. That's almost to 1, but not quite 1. So it's about right here. And then I need to go up 1 and then over 3. So I'm going to be roughly right here. I want to give myself on here a second coordinate, or excuse me, a third coordinate, just so I can make sure I'm drawing a straight line. If you have a ruler, you won't need this third one, but it's just helpful for me. All right, so I'm gonna go this direction. There we go. All right, let's do the other one. Subtract 2x, subtract 2x. I get 0 minus 6y equals -2x minus 4. Rewrite it. Divide everything by -6. I get y equals, -2 over -6 becomes a positive 1/3 x. That -4 over -6 becomes a positive 2/3. And look at that. We have the same exact equation. So our b is the same. And our slope is the same. So that tells me we have the exact same line. So I'm going to just on here, so you can see it, do this. I would recommend doing that on your paper as well. Just remember what I said about when you go to enter it in the program in homework or quizzes or tests, that you only plot the line once when you have this particular special system. But on your paper, I would go ahead and write it in this manner. In fact, I'm gonna do this so you can see it a little bit clearer. Let's see, let's have like this. Now let's enter our solution set. So previously in the one just above, our solution set was no solution because we had parallel lines that never touch. They don't share any coordinates. In the one we're working on now, it's the same line. So they basically share all coordinates. They have an infinite possibility of solutions. So their solution set is going to be written with the line in it. And that indicates that it doesn't matter what you put in for x and y, it will always work. It will always land on that line because we're essentially only graphing the one line. So in your solution set, you would write the x minus 3y equals -2. That's how you would indicate that this is the same line and all solutions are included. Now let's read our verse. Call to me, and I will answer you, and will tell you great and hidden things that you have not known. Jeremiah 33:3. All right, guys, I hope you're having a great week. I'll see you in the next video. Bye.